Okay. In the last class, we have discussed about the electrostatic potential, and we have found the value of electrostatic potential due to a point source. Okay. Today we will discuss about the electrostatic potential due to the electric dipole. Okay. We know what dipole is. Okay. What is dipole? Dipole is a charges which are opposite in nature, and they are separated by a small distance. Okay, here the small distance is how much? Twice a. Okay, O is center of dipole, that is, this is the distance A and this is distance A. Okay, now we will find the electrostatic potential due to this dipole. In the first case, we consider electrostatic potential due to dipole at any point on the axial line. Okay, we have to find the electrostatic potential due to dipole at any point on the axial line. Okay, this is our. Okay, now we know that this is axis of the dipole. Okay, therefore we can consider any point P on the axial line. Therefore we have to find the potential at P. Okay, write down. Let us consider a dipole having distance twice A. O is center of the dipole. Okay, all measurements are done from the center of the dipole. Okay, and P is a point on axial line of the dipole. Okay, where we have to find dipole, where we have to find electrostatic potential. Where we have to find electrostatic potential. Okay, P is at a distance. Okay, let us consider this is the distance of P from center of the dipole. Okay, let x is the distance from the center of the dipole. P is a point at a distance x from the dipole. Okay, at first we will find the electrostatic potential at P due to the point source plus Q. Okay, then we will find the electrostatic potential at P due to this minus Q sources. At first due to plus Q sources, and next we will find electrostatic potential at P due to this sources minus Q. Then we will sum up the values and we will find the electrostatic potential due to the dipole. Clear? So at first we can write electrostatic potential electrostatic potential due to source charge plus Q, V plus Q is equal to 1 by 4 pi epsilon naught, 1 by 4 pi epsilon naught Q by distance between the test charge and source charge. Here test charge will be at point P, where we have to find the electrostatic potential. So the distance is how much? This is the distance. This is the distance. What will be its value? Its value is, we can calculate. This is the value x, and this is the value a. Therefore, x minus a is the value of this. Okay, we can write this is e, this is b. Okay, so Vp is the distance. How can we find? OP minus OB. Therefore, its value is x minus E. Okay, so it will be x minus E. Okay, next, electrostatic potential. Electrostatic potential due to minus Q charge V minus Q is equal to 1 by 4 pi epsilon naught. Okay, charge is minus Q and its distance is how much? This is the distance, right? Minus Q to plus minus Q to P, that is AP. AP is how much? This is distance x and this is distance a. Therefore, its value is x plus a. Okay. Therefore, this value is x plus a. Clear? So now the electric potential due to the dipole is, okay. Now total potential. Now total potential due to the dipole is V is equal to V due to plus Q plus V due to minus Q. Okay, its value is 1 by 4 pi epsilon naught. Okay, this value Q by x minus A plus 1 by 4 pi epsilon naught Q x plus A. Okay, so we can take it as common, 1 by 4 pi epsilon naught into Q. Therefore, x minus A plus 1 by x plus A. Okay, then Q by 4 pi epsilon naught. Okay, what is its LCM? X square minus x minus A into x plus A. Okay, so its value is x plus A plus x minus A. So A cancel out. Sorry. Oh, there should be, this value is minus. Okay, if this is minus, then this is minus. Okay, then this value will be minus. Okay, then what will happen? Q by 4 pi epsilon naught, this is what? X square minus A square, and this value is x cancel out, A minus minus plus A, that is twice A. Okay, so twice QA divided by 4 pi epsilon naught. Okay, since this distance A is very small or less than this value, because, or this value x, because A is very small according to the concept of dipole. We know that the distance between the two charges is very small to create a dipole. Therefore, A is very small than x. Okay, therefore A square is also very small than x square. Clear? Therefore A square can be, this is small, can be neglected. A square can be neglected. Then this value can be neglected. Therefore, this is x square. This is also can be write as p by 4 pi epsilon naught x square. What p is? P is dipole moment. Okay. So this is the electrostatic potential due to a dipole. Clear? Okay. On axial line. Next, write down please. Okay. Now we will write or we will discuss. Now we will discuss about the electrostatic potential due to a dipole at any point on the equatorial plane. On equatorial plane. Okay? On equatorial plane we will discuss. Now this is minus q surge, this is plus q surge. Okay, these are the points and this is the distance between them, and its value is twice a. O is center of the dipole. Okay, now we have to find electric potential at any point P on the equatorial point. Okay, then let this is the distance x from the center of the dipole. Clear? And this is A point, this is B point. Okay, we have to find electrostatic potential at P. Okay, we have to find electrostatic potential at point P due to this dipole. P is at on the equatorial plane. Okay, so write down. Let us consider a dipole having length twice A. Okay, we center of the dipole, we have to find electrostatic potential due to dipole at any point P, at any point P, which is on equatorial plane. Okay, P is at a distance x from the center of dipole. Okay, center of dipole. Similarly, in the previous topic, we can find out the total electrostatic potential due to the dipole by first considering due to discharge and next considering due to discharge. Okay, now electric potential due to plus q surge is plus q is source surge. Okay, V plus q is equal to 1 by 4 pi epsilon naught q by distance. How much distance? That is pb. Okay, or bp. Okay, what is the distance of bp? This is x and this is y. This is a. So what is its value? From the Pythagoras theorem, we can write this value is a square plus x square. Fine. So its value is 1 by 4 pi epsilon naught 1 by 4 pi epsilon naught 1 by root over x square plus a square. Clear? Similarly, electric potential due to minus q source charge is how much? V minus q is equal to 1 by 4 pi epsilon naught minus q divided by AP. Okay, so its value is 1 by 4 pi epsilon naught minus q. What value of AP? Similarly, a square plus x square. So a square plus x square. Okay, now total potential. Now total potential due to dipole is V is equal to V due to plus Q plus V due to minus Q. So its value is 1 by 4 pi epsilon naught 1 by root over x square plus a square plus minus 1 by 4 pi epsilon naught. This value is Q. Okay, Q by 1 by x square plus d square. Okay, so its value is same. So its value is 0. That is electric potential at equatorial plane is 0. Okay. Due to system of charges. Okay, we have to find now electric potential due to system of charges. Let us consider this is the point P. Okay, where we have to find the electric potential due to what? Let us consider this is Q1 charge, this is Q2 charge, this is Q3 charge, this is Q4 charge. Okay. Okay, this is what? There are n number of charges. Okay, let there are how much? N number of charges, and P is the point where we have to find the electric potential. Let us, this is the distance, this is the distance, this is the distance, this is the distance, this is the distance for each charges. Okay, here the system of charges, how much charges are there? There are n number of charges. So first of all, this distance is considered as R1P. This is P point. Okay, R1P. We can find a position vector. That is 1P. This is R2P, R3P, R4P, and RNP. These are the position vector above the point P. Okay. So you can write, let there are Q1, Q2, Q3, Qn, n number of surges consist surges which consist in the system of surges. Now we have to find electric potential above point P due to this system of charges. Okay, now we have to find the point P system of charges. Okay, now we know the superposition principle in the chapter 1 that if we consider the what forces between two charges, then other force will not impact. Okay, so here we can write electric potential due to potential due to plus Q1 charge is these are the plus Q charges, all are the plus Q charges we consider. Okay, so potential due to plus Q charges is V Q1 is equal to 1 by 4 pi epsilon naught. Source charge is Q1 and distance is R1P. Okay, similarly, I have to raise this. Similarly, potential due to Q2 charge is 1 by 4 pi epsilon naught. This is Q1, it should be Q1. This is Q2, which is the source charge in this case, and distance between them is how much? It is R2P. Okay, R1 is this, and R2P. Okay, similarly, we can write for Q3 size, Q4 size, Q5 size, Q n number size. Therefore, similarly, potential due to Qn surge is 1 by 4 pi epsilon naught Qn, okay, divided by Rnp. Clear? Okay, so we find that the potential due to even plus Q1 is this one, Q2 is this two, Qt similarly we can write Q4, Q5 and Np is how much? This. Okay, now for the system of charges, total potential is V. Now total potential is total electric potential is V is equal to V due to Q1 surge, V due to Q2 surge plus V due to Qn number surge. Okay, so how much? 1 by 4 pi epsilon is value 4 pi epsilon naught Q1 by R1P plus 1 by 4 pi epsilon naught this value Q2 by R2P plus plus 1 by 4 pi epsilon naught Q N by R and P. Okay, we can simplify 1 by 4 by epsilon naught 1 by 4 by epsilon naught Q1 by R1P plus Q2 by R2P plus dot 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 Qn by Rn P. Write down. Okay. This is the electric potential due to system of charges. Clear? Okay. Thank you.